So go ahead and turn that on.
Okay.
Yep. So today Drew is going to do his first soldering of a kit, but we're also going to do, this is a board that I designed for the channel and just for myself. It's a passive mixer board. Oops. It's a passive mixer board, and it's got 2 inputs, 1 output, no power needed, and he's going to put these 4 resistors in, and we can test it or not, but this is just to get him started, a way to practice.
Yeah, I've never soldered before. It's pretty amazing, considering what jobs I've had in the past.
Yeah.
So
this is a Hakko tip cleaner. We've got some silver solder, non-lead. This is the kit. I just put this here. It's my Digi-Key Pcb Ruler. Pretty cool. Definitely a premium ruler of this type. It's got some gold tinning, but basically has all sorts of measurements on it and information about mils and millimeters. It's got a millimeter side and a English standard or empirical side. And then what else? It's got screw gauge holes, and we've got wire gauge holes, and then pad sizes for different types of SOPs and surface mount chips over here. So it's great reference. Digi-Key. They don't pay us for this, but I just thought I'd plug that, so I'm going to take this over here because we don't need it. This is our kit from WHDTS on Amazon. He gave us this kit as so full disclosure, this was given to us. I haven't actually put it together yet, but he did it so we would give a review. I gave it a 5-star review, but the one thing I wanted to mention about it is that it doesn't come with enough header pins. So if you are into this, you're going to have to deal with your own header pins. It needs 2. It's just 2. And also it has instructions on the site, and it has a photograph on the product page. When I say site, I mean the Amazon product page. But if you type in WHDTS DIY Electronics 16 Music Sound Box, that's the kit that we're working with today. First, we're going to do the passive mixer board, and Drew's going to get acclimated to this process.
Yep.
So while the weller heats up, I'm going to basically tell him, I'll tell you, Drew, how this works. So obviously the hot end of this is from here down, so don't touch that.
Right.
When you plunge it into this Hakko tip cleaner, it actually makes the end of the tip very shiny, and that's where you want it to be.
Okay.
But in addition to that, you've got your solder here. Mm-hmm. We also have this tool. It's a magnifying glass that allows you to magnify things that are too small to see. And we've got this device, which is a German engineered but open source unit tester. So you put a single part in here and you close the lever there, and then it'll tell you the capacitance or what kind of part it is and things like that. So the first thing we're going to do is, so proper shop stuff. What you want to do is, you have those, so on the mixer board you're going to be adding those resistors. The resistors are on your right.
Yep, these.
And those are 1.1 kilo ohm resistors, or actually I think they're just 1 kilo ohm resistors. And what you would want to do is do a little bit of quality control on them by putting them into the tester and making sure that they're approximately 1 kilo ohm, so that you know that your part is adequate. So
okay.
Why don't you just rip one out of there? You can either rip it out or cut it out. These are your... By the way, we have some other tools I should go over.
Yep.
Okay, this is a flush...
out?
Yeah, hold on one second. This is a flush cutter. It allows you to cut right down to the board or right down to the edge of the thing. You can actually use that to remove them if you want, but it's okay that you do it that way. Some people don't like to do it that way because it leaves a little bit of crud on the end, but it's not a big deal for our application. And then these are actually jewelers. I don't know if there's a name for this, but I use it. I mean, there probably is, but I use it to bend wires around, and it's not a pair of pliers. It's actually a bending tool for bending wire. So you've got those two tools at your disposal.
So should I bend this now?
Yeah, I would give it like a 90-degree bend on both sides, leaving a little bit so that you don't damage the actual component. So about 1 millimeter out. Yeah, that's fine. Okay, and then show them how you've done that. Tip that up a little bit so it's a little bit easier to see what you're doing. Okay, so you got that bent. Now what you want to do is you have that thing on your left-hand side that does that. And you'll notice that on the turquoise colored thing, socket,
Yeah.
You would put one leg, so the resistor has two legs and you've bent them.
Yeah.
One leg goes on one side of the line divider. So it's like a cross. No, not like that. So it's like a cross, and you've got the ones that are near you, and then on the other side of that little riser, there's ones that are farther.
Yeah.
And on one side is one part of the circuit, and on the other side is the other. So you want to put them across that bar.
Just
and
like
just
that.
slip them in there real nice, and then pull the lever down.
Just like that?
Yeah, and then pull the lever down. Okay. Now press the blue button, and hold that up to the camera so they can read it. So it says unknown part or damaged part. So how about taking the leg that's on the other side of the divider and putting it into the lower section? I'm not really sure why that didn't work. Alright, so keep that as close as possible. And you can see it says a resistor that's at 985. That means it's within 15% of 1K. That's what it claimed. And that's like a 1.5% difference. Or I'm sorry, 1.5% difference. And that's within tolerance. So we'll say that that's all right. I would go ahead and test the other parts as well. All right, and as all benches need, we have a little thing. If people watch my other videos, this is our toxic waste, and this is where we place things that are toxic waste. So I'm just going to set that over here, Drew.
So these?
Yeah, so throw that away, discard that. Yeah, nice. All right, it's good. You don't have to worry too much because it's going to be forced through a board anyway. So.
Cool.
Great.
Okay.
Right. So then just kind of keep it as close to the divider as possible. Yeah.
It's close to the divider.
Yeah, just like not the first one at least.
Okay.
And don't push them too hard. And then, yeah. And then
Okay.
just hit the blue button. And
I actually can't see the screen.
I'll tell you what it says. Okay, it says 985.4. I suspect that's pretty close to the last one. These are pretty high quality. So let's see what... In fact, it's almost identical to the previous one. I believe these resistors came from... Let's see.
Okay.
Those resistors came from E-Projects.
Okay, that one, same thing.
985.4. So they're pretty much on. You can test the last one, but it's looking like they're pretty consistent, and that's a sign of a good quality part, is that they're all coming in at the same amount. So they were all manufactured right next to each other. That's why they were on the... So that one's a little bit more resistant, and that's okay. It's 989.5. That's fine. They're pretty close. I mean, if you really wanted to be nitpicky, you could get them exactly close. And working with older technology, like 1940s technology, you might want to get them as close as possible, but generally this will be fine for our application. So what you've got there is your board, and you'll notice at the bottom towards the single output, there's two sets of four, and so there's four pairs of what are called pads.
So like here?
Right, or traces.
Okay.
So those traces, you're going to put them in vertically. So one is towards me and one is towards you. Now let me mention this about a resistor. A resistor doesn't matter what direction you put it in, but other parts, it does matter what direction you put it in.
Okay.
This is a something that I came up with. Basically, this is for holding a cell phone. And these are just little clips that Julian Eilert likes to use, and I find them to be really useful. So what we're going to do is we're going to take this board, and we're going to try to get it... See, this is bendable, so I can bend it in any orientation. And we're going to hold the board in there so that you don't have to actually hold the board at the same time that you're doing the work. So now the board is nice and in there, and you can actually move this around to orient it towards yourself a little bit more if you'd like.
Yeah.
It's just a key thing is that you're going to have a hot soldering iron.
Yeah.
And I don't want you to touch it because it will burn.
Yeah, I feel that it would burn.
So I'm just going to use the hot iron here to cut a piece of solder off the spool and put the spool aside, back in there.
Okay.
And then what I like to do is just wrap it around my fingers. So go ahead and wrap most of it except for like the last inch around your hand or finger. And not too tight. It's just to hold it. See, that's a little tight. I wouldn't have done it that tight.
Okay.
Okay. And now what you want to do is grab the, and I'll just get the camera up here. You want to fit one through each hole. Okay, and don't worry about pushing it all the way down yet.
Okay.
We'll take care of that in a second. Okay, golden. So what we want to do now is actually flip it. And the way we're going to do that is, I'm going to take it out of here. And
Okay. Yeah, go ahead and do your thing.
yeah, let me just do my thing real quick. We'll just do that. So as you can see, I can use it free. I can use it like when it's anchored. It's a pretty good way to hold a board. So what we want to do now is, if you'll hold the camera for a second.
Yep.
We just want to bend it up so you can see the bottom. Put that there. Okay. So now you can see the bottom, and you can do your soldering.
From right there, yeah.
Yeah, from right there. So you'll be able to take care of all of that. All right. So generally what I would do at this point is pull one leg down. But those are pretty much in there. Well, there, that one pulled. And all that's going to do is just make it a little bit less high profile than you had it.
Yeah.
And there's actually a name for this method where we're stepping, because the resistor is longer than the the space between the two holes, it's going to sit up on one end, and that's okay. All you're going to do is you're going to put the iron underneath the wire that you're going to be soldering.
Okay.
And then you're going to push this solder into the wire. So you're heating the wire.
So, okay, so...
Yeah. Once you got one in, you're just going to do the top ones of all four.
Should I touch with the solder first?
Touch with the gun first. Or the iron. And then just push that into the iron. Alright.
Yep.
It's alright. It's your first time. Push it in. Now push in your left hand. Push with your left. Into the iron tip. You can kind of see that it didn't go into the hole. So let me give you an example. If you put your iron right where the wire hits the hole, your goal is to get the solder to flow through the hole. So you see how there it is no longer...
Yeah.
So that's kind of what you want to do. Okay, so... Alright, so you see what I mean though. It flowed in a little bit, and now that one's in, and we're just going to repeat that for the remainder. Just the one side of it. You don't want to bend them all the way. You don't want to bend them all the way sideways because look at that. Look at that burn. Bend it. You don't want to bend it all the way sideways because I don't know. It's better not to. Can't tell you why.
All right, so
next
round two.
Round two, yeah. So the first thing you want to do is clean the tip off. Yeah. Put a little bit of solder on the end of that tip first. Yeah, just push that into the side of it. Great. And then what I want you to do now is look at your work and ask yourself, does it look like the first one, the demo one? I think you did okay on the second one.
Yeah, the second one is okay.
It's that one where it beat it up.
Yeah.
The third one. So all you got to do is with all that together.
Fourth one actually looks pretty decent.
Just hold that so that you can see it.
Uh-huh.
This is less for the camera and more for you. And just watch what happens here.
Oh, she goes in.
So she goes in.
Yeah.
So that's a key aspect of this. So just clean up the rest of those.
Okay.
Okay. I think I'm good with that.
Yeah, I think we're all set.
All right, go ahead and keep going. Do the rest of them. In fact, let me see if I can get a little bit of your... Okay. I feel like... So let's talk about surface.
Mm-hmm.
So if you look closely at this one, it actually has a clouded surface, and some of these others, and this one is particularly bad. So the reason why you worry about that is because it really needs to be more like these, where they're very, very... This one's actually not fully enclosed, but these are very shiny. And if it's not shiny, that actually indicates that there were impurities, and it didn't quite solder. So you can just kind of heat it up again, and see there, it went perfectly in.
Yeah.
And I would just repeat that for that one, actually. That one looks all right, although you're a little light on the solder on that one, but I think I can... There, that fixed that, and I'll just fix it. Okay,
Cool.
now you've got a perfect soldering job, and it looks like all the other ones are pretty good. I would just clean that up a little.
How'd I do?
I would give you a 6 out of 10 on some of them, and because I had to fix them, and I'd give you a 10 out of 10 on some of them. So
Nice.
So that's looking pretty good. Now you have to do the next step, which is to find the flush cutters, and just snip them off about 1 millimeter up from the bottom. And then, yeah, once you've got all those pieces, whoa,
Oops, sorry.
it helps to hold them so they don't fly, because you want to keep these. So just hold the end. It's not hot anymore. It doesn't take very long. And don't worry about covering up the camera or anything. And we're just going to keep these. Now that one you cut a little close. You want to cut above it, not on it. It's okay then. Maybe it was just like wicked up, as they say. Okay, we're going to keep these pieces, not only because I make jumpers out of them, but because we actually need them for jumpers later in this project. Although these are not my favorite ones because they're not very thick. They are made of tin alloy. And...
Cool.
Alright. Okay. Alright. Now, the next phase of this video is to identify where on here we're going to place these parts. Now I'm going to help you out here. If you flip it over, you can see that there are several things going on.
Mm-hmm.
I'm going to teach you the right way, not the way I do it.
Okay.
Okay? The right way is to find the lowest profile parts and put those in first, and continue that progress all the way up to the last part.
Okay.
I mention one special thing. This is it's basically a tiny speaker. It beeps, okay? It's called a Piezo Buzzer, okay? And this and any other audio part, like if it were to be like a microphone, because microphones come in about this size, any audio part, you got to be careful with the heat. So when you're placing, when you were soldering these bits here, you were using what we call a dwell. You were holding it and dwelling, and it's referred to as dwelling. And your dwell time is something that you have to manage. If you were to dwell too long on an audio part, not so much this Piezo Buzzer, but other parts that are like that, you could damage the part, because the part will actually heat up. So just so you know that. Now you can see here that there's markings on the board itself. And if I hold this close, the audience can also see that there's plenty of markings on this board, and it looks like EQ Kit is the actual manufacturer. So what you want to do is you need to identify the parts. So let's go through the parts one by one, and we'll just discuss what they mean, and then we're going to place them in the board and do them in segments. So let's do the first ones first. So these are called Zener Diodes. And they're used in various applications for high frequency and audio and radios and things like that. And basically they have a marking on them. One side is black and the other side is not marked. And that's actually a particular side. So if you look at where they go, they're also marked. Now there's 3 types of diodes, or there's 2 types of diodes and 3 diode parts. And they all have markings on one end, and that's because they have to go in a certain direction. The purpose of this diode is to stop DC current from backflowing. So it goes only in one direction. It's designed, hold this up here. It's designed to stop current from traveling the other direction. So if it were to be placed in reverse, it would stop current from flowing in the wrong direction for this circuit. So this is one of the parts where you have to put it in the right way. Luckily, they've marked it for you, and it says D1, D2, which indicates that those are similar. So I'm guessing that these are the two parts we're going to put in there. So let me show you a different way of putting them in without using the bendy tool. I like to put one in and bend it on the board, pull it out, stick it in, bend it on the board, approximately to where it's going to be, pull it out. Now you've got the bend started. And then I would just make sure that my black side is lined up with the indicator. And we're just going to put it in, slide it in place, and then bend the backs. I told you not to do that last time, but it's okay for this. So that's the correct way to put that in. Why don't you put that one in?
Okay.
And make sure to stay within the camera. You can also just do it with your finger. You don't have to actually stick it through.
Yeah. Just get this in. All right. Okay. There we go.
Okay, great. Now, don't put any more in. Those are the lowest profile parts. So what I want you to do is, another trick I use with these little holders that we were using before is without the thing that looks like an alien. Just putting it in there, you can kind of hold it off the surface, right?
Mm-hmm.
And it may be tilted towards yourself, or in this case towards the camera. Just very carefully solder those two. You don't want them to bridge, meaning you don't want the solder to flow too much that it connects them both. So go very light on the solder. Make sure to clean the tip.
Okay, how about that?
Let's take a look. A little light here. Let me just clean it up.
Okay.
Okay. Cool. Perfect. Great amount. You did really good on the amount. Okay, now you want to cut off the legs.
Right.
And I would cut like that with a slight angle there. But being careful not to damage the board. Or you can also bend them around if you... Yeah. You can see how that's a little more harried than when they're straight out. Yeah. And it goes flying across the room.
Yep. There's one on me somewhere.
And it fell. Yeah, and I'll step on that later.
Yeah. or me. I'm wearing socks too.
Yeah, okay. Yeah, actually
It'll come back to haunt me.
It'll get you, yeah. It'll be like right through your toe, and you'll be like, fuck.
Not the first time in the lab.
Okay, that's great. Well done, Drew. They look shiny. Another thing I wanted to tell you about these is that it's actually also known as a germanium diode, I believe. That's another name, and that's because it uses a piece of germanium. You can read about those online. Okay, let's go on to the next part. So I think the next part is that diode that you were ready to do, or you could do any of these resistors. Now these resistors have different values, and so do on the side of the diode there's a little N number, N4007, which indicates the strength of the diode, which has to do with the amount of resistance in the reverse direction. Okay, and then once we've got all the resistors in, we're going to do these sockets for the chips. These integrated circuits, ICs, or chips, whatever you want to call them. These are made by Texas Instrument, and there's a correct one and an incorrect one to put in. So you have to make sure that the 4011 goes in that one and the 4066 goes in that one. What I would do with that one is I would use a clamp to hold it in place, because that's got so many legs you got to keep them all in place. And then this is a transistor, which is basically like a current controlled switch. We'll just call it that for now. So you apply current and it closes, or you remove current and it opens, or the opposite depending on what kind.
So this guy's going to go right here, right?
Well, before we do the diode, well, yeah. Okay, so what do you need to do to put that in correctly?
So match what I'm assuming this gunmetal probably to right there.
Yeah, that looks perfect. So, sounds good. Are you putting it in on the top or the bottom now?
Top.
Okay, good. Just making sure. It's easy to slide off.
Indeed. Okay, she's in. Now I'm gonna start the weld or the solder. Take the tip, clean it off, get a little bit on there just to start it, and then I'm gonna place my solder down. So this is actually pretty hard to... Oop, that might be a little too much. You know, that guy's in the way. Get that off. Okay. Ah, that was perfect. Okay. All right. Now I'm just going to kind of look at my work under a magnifying glass here. Can't tell if that's light coming through. Yeah, I'm going to have to re-hit that. A little bit of problems with this one right here. There we go. Alright. Some of these could definitely be better, so I'm just gonna hit the ones that I think could be better.
I'm back. Still doing it, huh?
Yeah.
That's good. Slow and slow, Drew. Low and slow.
I'm just trying to touch up on the ones that... Oh yeah, there we go. Alright. Yep.
Excellent. Alright.
So, Herb wants to inspect those.
I will inspect those. Normally, you inspect them yourself, but I would clean that one. It's a little bit dirty. There's a lot on there. Alright.
Yeah.
It's pretty good. As a lot of these, I can see. What is happening there is that you're a little bit new, and so you're afraid to put too much heat on it, but it's alright with resistors. You can put heat on a resistor. So, excellent. Alright, I wouldn't really touch any of the others. You did pretty good. I'd cut them off and...
Cool.
Now, like that, Drew.
Okay.
That way they don't fly.
I won't send pieces flying.
Excellent. Very nice.
I think I'm going to have to buy a soldering kit now.
Talk to me before you do.
Okay. For sure.
I'll help you fix some good stuff. Okay. Great. We're, I don't know, 30% of the way there. Well done, Drew. Those are really tight and in there. That one's a little off, but it's okay. It happens. I wouldn't worry too much about it. Looks pretty good. Let's see. The next highest profile is probably these. Now,
what about these two?
Those are a little bit the same, but I would put these on first. The thing is that there's no way to tell once we have them on there, so I'm just going to mark it with a pen. Hold on.
We also have some resistors, right?
Oh yeah, there are more resistors. Let's do those next. But I'm just going to mark this real quick.
Okay.
So, and we're going to overheat soon, so we're going to have to take a little break. But what I've noticed is I'm just going to put a little black mark there, and that way we know that's the 4011.
Okay.
Okay, so let's take a break because the camera's overheating.
Cool.
Thanks, Sony, and we'll call it a day. So Drew is putting in the other resistors. He's measured them, and he is now wrapping those up. And I think he has learned a little bit about the color codes on how to read the resistor's value based on what the claim is. Of course, we did notice that one of the resistors was a little bit high. A lot of resistor kits come with a little guide like this. This one's from Velleman that give you information about that. And I was just teaching Drew a little bit about how that's done. He did read it backwards the first time, and then we flipped it around and read it the other way. I may have told him wrong, I don't know. But we're just getting to the next step, and then we're going to put in the sockets. All right, whatever, I give up. All right,
okay.
That's fine. All right, now the tough part. Doing these sockets. So the sockets are actually both the same size. And, you know, there's a little notch in the end of the socket there, Drew. Okay? And it matches a notch in the chip, which is matched in the place where the socket goes. So we'll just do the one on the outer side first because that's a little bit easier to deal with.
Yeah.
So it's actually really good that we did things in the right order because... get a little bent out of shape. Because actually I think we can do both at the same time.
Nice.
Because you put them... Because you put all the parts in... Hold on to that for a second. Because you put all the parts in the right order... hold on. So I have this nifty gadget, although it's not the niftiest gadget, but you can put the socket in there, or the IC in there, and then pull that closed, and it'll straighten them. So let's see if I can get that in there. All right, again matching the notch. So because you did them in the order of height, we can still put these in. Now,
Sweet.
What I do when I can't do it is I'll hold it in place very carefully on the end, but we're not going to do that. You can also put a piece of tape. Why don't we do that? Just to hold them in place. So hold on to that. Don't let it tip or anything.
Okay.
I'll just take a piece of tape and we'll just put it across there. All right. All right, and then we'll flip it.
Okay.
Okay, and then just pull that out of the way. Okay. Now, without moving it, you just want to go down one after another doing each one. Just be careful not to bridge them together, and that does include that square-shaped one.
Okay.
And otherwise, it looks pretty good. I think you shouldn't be too bad. Just try not to move it around too much.
Okay.
Make sure your chip's nice and clean.
I feel like there's going to be a lot of like elevator music playing while I
We'll just speed it up.
I think I bridged.
Let me see.
Definitely bridged on that.
Right, so just pass the... pass it. You don't need more solder. You have enough on that one. You just want to kind of get it to wick up onto it. All right, we're back. So Drew has put in the IC sockets, and because you know all the components, they have little writing on them, but there's some special sauce in this mix. We don't know what it is. Although I can tell you that it's that big, you can kind of see through it, but we don't know. Anyway, it's probably a ROM chip that has some special properties. It's no big deal.
Cool.
Like, I've seen Nintendo on the chips. It's like the entire NES, and they put a glove on that too.
Yeah.
Okay, so anyway, as I was saying before we got interrupted, so Drew put the IC sockets in fairly well, and all the resistors are in. Now we're going to do the final components, and then I'm going to take over and do some modifications to this kit. Just give it a slight bend in each direction to hold it in there. Okay, and then we might as well take this 104 capacitor, and we're just going to put this in the tester so I can show Drew and the camera what the value is. So this is a common disc capacitor. It doesn't matter what direction it goes in, but lots of electrolytic capacitors, which are the sort of the barrels. I might have one. Here's one. Okay, so this is an electrolytic capacitor, and it has a negative side and a positive side, but these disc capacitors do not. Electrolytics are prone to failure. So this one reads a capacitance rating of 72.7 nanofarad. So that's a 72 nanofarad capacitor. I don't know. It has that capacitance. All right, we're going to take it out of there. Yeah, cool. It's slightly magnetized. So pull it off there. All right, any final words before I sit?
No, I mean, for a beginner, I definitely, take your time. Make it so that, like, you get as even as a surface as possible. And, yeah, I'd say that, as intimidating as it may be, soldering isn't too bad, in my experience.
So you had a good time. All right.
Yeah, I had a good time.
Well, we're not done yet. We're going to get it working. So let's just go through the remaining motions here. So if you wanted to do this to the instructions, you would put these little switches in there, and once they're mounted, you could control the sound that way. I'm actually going to... I have some other stuff lying around, and one of the things I have is these Dupont connectors. So what we're going to do is, instead of having to go to the board to do that, we're going to put these headers in. So there's actually these headers, which is so that you can get the sound in and out, and to do some other stuff, I guess, through there. And that's supposed to sit in there like that. But they forgot to give you... maybe they updated the design here, because I don't see where that other jumper comes out. Unless we did something wrong. Wait a minute.
We fudge up?
We may have put that... luckily I have a lot of those capacitors, but this capacitor may be in the wrong place. I don't know where else it would go. See, there's this thing, and I'm wondering what that's about. Because you can't see that on the schematic. Or on the photograph. And because you can't see behind the daughter board, it's hard to know where that is. And I have yet to find exactly how to, on that page, view the actual instruction sheet that he did say was there. So it's kind of hard to find that. Honestly, I would have given this probably a 4 rating, but I like music boxes and I would like to see him sell more of them, so I gave him a 5. He approached me because I bought stuff for him before, and he's waiting for me to ask for another one. So we may be doing some more from this seller. Again, it's WHDTS DIY Electronic Music Box. So I'm going to quickly put this header in. So we'll have that. Okay, that looks good. So there's that header. Now the modification is going to be to get this stuff to have headers. And when I look at it, it's... Let's look at this real quick. I don't know if you're going to be able to see this detail here, but I'll point it out. I need a pointer. I use the solder. Okay. So normally what would happen is you would put the two mechanical grounding, or not grounding, mounting pins here, and then there's these three parts of the switch. Well, you can see that this part of the switch is not connected to anything, and that this is the open close on that switch. So for that reason, I can actually create a jumper between these two. The reason why I would do that is because I don't think if I have a dual pin header that I'll be able to fit those pins directly. Well, maybe, but I don't think they're going to fit. So anyway, you take this header and you cut off the ones you need. So we're going to need 8 of them. We're going to just start with the first 2 here. It's a little complicated, but basically I'm going to get one mounted here, if it even fits through. It's kind of a tight fit. Okay, that went through. So we're going to get one mounted there, then we're going to skip a hole, and we're going to mount that there, and then I'm going to create a jumper to jump them. It's not what I would like to do, but it's what I might have to do. I guess option B is, well, no, I need that clearance, so let me just push that through. Okay, so we're going to do that, and then we're going to create a jumper. So I'm just going to do the first one real quick. So I'm going to put this in there. There we go. Perfect. Now we have to create a little jumper, and before I even solder it, well, I do kind of want to solder it in, so let's start by doing that. Okay, that's soldered in. Now we just have to bridge them. I don't even think I need a jumper, actually. No. Alright, so we have these little legs that we've cut off, and I'm just going to make a little L shape. Right? Actually, I may not even make the L shape in the beginning. I'm just going to get that in there. Sorry that you can't see. Okay, we got that in there. Now we just got to bend it over, solder that, and cut it. And in fact, I'm going to wrap it around. And now we've got a little bridge between the two. Excellent. And so we're just going to repeat that for all of them so we can have headers that connect to the switches. And I'm going to cut that. Well, I can leave that. It doesn't really matter. So we did that once. And we got to do it 3 more times. And that should let me plug these things into there, and then I can put the switches on the other end. Maybe. In fact, I have lots of these Dupont connectors. They're super useful to have in the lab because you can do all sorts of quick stuff with them, and breadboarding or whatever. So I need 8 of them. That's 9 of them. And now I can plug these in here, and then I'll solder these to the ends. But eventually what I'm going to do is plug them in, is to use the double plugged ones, these, and I'm going to put them into a Raspberry Pi GPIO. I think I can do that. I might need some sort of small interim circuit, but anyway. Let me just clip these off. All right. what's nice about the holes being a little bit small is that when they snap in there, they're pretty much in there. See, that one didn't actually quite do it right. And that's going to help us keep them in place while we mess around with them. There we go. Alright, just line this up a little bit better. Great. Let's do the soldering then. It's always good to work on in a heat resistant, burn resistant material. So I have a piece of heat resistant Pyrex that came from the kitchen that I no longer use in the kitchen. And excellent. Okay, now we just got to put in the jumpers. So I'm going to repeat the same process I did before. So what I did before was I took a piece of solder. Let me get some more solder. Okay, we took a length of solder and we just kind of filled the hole with a small amount of solder. Okay, a little bubble of it there. Alright, just the minimum amount. Alright, and now we're going to heat it up and feed the jumper in. And we have to do it kind of quickly. It's hard to get a good shot of it. Let's see if I can improve that scenario a little bit. Alright, so the light, okay. So that's what we're doing there. We're just sticking in a piece of wire. Actually have enough solder on it. Look how dirty that tip is. I don't know if these are the best tips. So close. You have to be very careful because it's so freaking small. You could easily bridge them. Bridge the wrong one. You don't want to move it while you want it to be in a static position when the solder is cured, because otherwise it can get a bad connection. So we're just going to hit that up one more time. Honestly, I'm just going to give it a tiny smidge more because I just didn't like the quality there. Alright, now we're going to do the bridging. So we're bridging that way. This is again where these jeweler's tools help a ton, because you can get in there and do some pre-bending and pull things around without having to worry about your fingers. Alright, so that one's good. Let's bridge that one. And the final one. Cool beans. Alright, now we've got headers where there were switches. Now we got to do the other end. So let's just do the other end real quick. Now this one is going to be a little bit tough because we don't have exactly what we want as far as we don't have exactly a way to hold these things together exactly the way we want to, so we're just going to wing it. But our goal is to connect these two things. Okay. Now see, my other option is to do this, and I'm nervous that it's not going to hold for very long. It can hold it, but not very long. So we're going to have to just do this thing. Hold on a second. Get them all the ducks in a row. Clamp that. Okay. Nice to fit that other one in there. Oh well. Okay, so we're going to start with this one. Well, wait a minute. It was the middle one. Yeah.
What's going on?
Well, probably two of them are the same. See, there's three legs. Well, this is where the multimeter comes into play. So let's demo that. Where is it?
I'm trying to find that when we go to the restroom.
Yeah, go.
Dude, I might have to make a quick stop to Best Buy after today.
Oh yeah. Don't buy from Best Buy.
Oh, for my phone.
Oh, for your phone.
This iPhone. Good reason not to buy Apple products. They quit after 2 years. It's been giving me problems for like 2 weeks to where it'll.
What kind of iPhone? Dude, I buy one. I have an
7.
iPhone 5. Alright, I'm not sure when it stopped recording, but now that I've thought it through, I actually am not going to use the switches at all. I'm just going to plug these in and use a jumper. So we're not going to actually do that step. So this is, the headers have been placed in the places where the screw was. We did a little Jedi mind tricks down here to get all those things connected in the right way. And it may not be pretty, but it works. Now we just have to do the daughter board. So let's start on that. Now this is the part where I don't really know. Alright, so we're back after another camera snafu. Alright, we're back after a couple of camera snafus. And apparently Drew and I put something in the wrong place. There was a 104 capacitor that came with the kit, and we put it here, but I should have been paying more attention because I knew that there was a header that was supposed to go there, so with a lot of fiddling I was able to get that capacitor out of there, and I put a different header in for the power, so you need power there. And then there's a ground connection and an ABCD. I have no idea what that's for. And then our ICs go in there. So, again, I marked the bottom where the 4011 goes in. And I guess I can just put that in now. So there's our first socketed IC, 4011. And now the 4066BE. And if you heard earlier, or maybe I'll just play it now, I was talking earlier about the sound effects. Those are on the daughter board. Kind of convenient that it's on the daughter board, but there's not any way to buy other daughter boards. And I don't know what the chip is, but it's obviously... Where'd the daughter board go? Yeah. So this is the daughter board, and you can see that it has connectors, and it's got something on the top there. And if I look at the drawing, I don't see where that capacitor goes. However, on the back end, there are these two connections, and I think that's where that capacitor goes. That's my guess. So now it's a matter of getting this daughter board mounted, and they could have done this in a multitude of ways, and I am tempted to mount it like this, but it doesn't have enough clearance and I'm just not feeling it. So right there. So now what we can do is, in the correct order, which would be the order of the wiring, we're just going to mount. I mean, this is longer than you need, but, you know, I don't really care. This isn't... If it does go into something, I can deal with this management. So our game plan is to just get 5 of these in there. Alright. So I have this tiny jeweler's drill, and I'm just going to make these holes. Well, it fits right through there, doesn't it? But I got to make it slightly wider, so I'm just going to pitch it back and forth. Yeah, now that hole's a little bit bigger, because we don't want to spend too much time there. Then we'll solder them to the main board. Okay. And since Drew left, I turned my iron up. Such a cheap board. Oh my god. Alright. Yeah, it's just... Just caking it. Alright. Alright, no bridging. Looks pretty good. A little cloudy, but there's a chance of meatballs, so. Now we're just going to cut them off. Ooh. Oi. Vey. Wow. Okay. Alright, you got it there. Now we just got to do the last two. Let me get those in there. Well, she ain't pretty, but she'll chooch, according to AVE. I think that would be an AVE comment here. I think she'll chooch. Smells like plastic. Bing! Bong. Alright. Well, it's not the prettiest thing in the world, but it should work fine. Looks alright. It's not my favorite job, but okay. Now we just got to do the other side. So the other side is going to be equally problematic, but it looks like those holes are slightly bigger. We just have to make sure that we get everything in the right order. We'll deal with that later. Alright. Alright, let's start this off in the right way. So I love these little clips. Julian, Eyelet. They're just great clips. And they were cheap. They came from China. I think I paid $5 for like 12 of them. All right. Alright, that's just boiling. That's hot. Alright, so we got that. So we got the daughter board. It's together. I mean, technically, yeah. So now, what else? At 104, so got a bunch of 104s around. Here's a 104. There you go, 104s. So I'm going to need to put 2 more of those jumpers on. And I have to say, the weakness of this kit is the daughter board. I would like to buy just the daughter board and refactor everything else, but so it looks to me like the capacitor goes between this and this, which is annoying to say the least, but I've seen worse. Alright, so we're going to pull that leg out. And we're going to pull the other leg out. Shouldn't be nearly as bad. Alright. That's where that goes. Definitely. Felt it cinders there a little bit. Yeah, bub. He left a while ago. I'm still trying to fix this thing. Okay. Not my favorite thing in the world, but whatever. Got your positive, your negative. Oh, yeah, that's correct. And then got your negative. I think you can put control voltage here. Well, Kind of cool. Well, thanks, Retro Friends, for coming and hanging out with us today. Drew is going to make another kit in the future, and oh, I didn't even realize that. Cool. Well, take care, Retro Friends. We'll see you next time.